similar to, consistent with what Dougal was pointing out, is that you start with limestone, and limestone is calcium carbonate, and the process of making limestone into cement releases that calcium carbonate, and so releases that CO2 from the limestone. And so the co-founders came up with a process where you start with a different rock and you don't have that CO2, but it also co-produces a product called magnesium hydroxide, which actually captures CO2 from the air. And so the entire process becomes carbon negative. So we produce the same cement that you use to construct buildings today. We do it through a process that's carbon negative instead of very carbon positive. And we also, at scale, believe we can do it at or below the price of existing cement. So I can explain more about that as the panel goes on, but very much appreciate the opportunity to talk with you all today.
Perfect. Thank you so much. And last but not least, our local Lisa Morey.
Okay, thanks, Matt. So I'm Lisa, with owner and founder of Colorado Earth. Started the company here in 2017 after a long background or history working with Adobe. Was introduced to working with mud. But basically, this is using clay as the binder in replacement of cement. Although a small percentage of Portland cement is traditionally added to Adobe mixes. But now I'm producing compressed earth blocks and doing lime stabilized blocks here in Golden. So this picture is at the block yard off Highway 93 in Golden, where I'm set up right next to a quarry. And the quarry mines aggregate and rock, and basically screens out the sandy clay material and kind of puts it, either chucks it back in the hole or puts it off to the side. And that's what I acquire for the production of the block. So it's trucked over, half a mile to me, and then processed in a compressed earth block machine and mixers and conveyor belts to produce blocks for houses that our company also designs. So these blocks are obviously, made here locally. It's a regional material, to address local supply chain issues. It's also fireproof, so we're supporting a lot of reconstruction back in the Boulder, Boulder County with the Marshall Fire, and working actually with Jim here on the line to do a life cycle assessment of the production of the material. So, really calculating exactly what's going in and out of the production facility, cradle to gate, doing kind of our lime stabilized blocks. That will be kind of a baseline as I introduce other materials into the mix design, either from the waste stream of construction materials and or other, opportunities to utilize a waste product that could potentially replace the need for the lime, which is our most currently high embodied material in the mix. So yeah, excited to be here. Thanks for having this conversation with us.
Yeah, thanks, Lisa. We're excited to have you all here. And with that, I'm going to stop sharing my screen. We're going to focus on just asking questions directly to our panelists here. And I have a few lined up that we're going to start with, but I would love if the audience, if people want to ask questions, I'd encourage you first to raise your hand if you want to actually ask the question yourself. But you're more than welcome to drop things in the chat as well. We actually have a question that I think is for me in the first slides I brought up about how much of the, I think 11% of global emissions for concrete is buildings versus other uses. I don't have that at my fingertips, Michael, but if someone else on the line knows that, it'd be great if you could drop that answer into the chat. But otherwise, I'll get started with my list of questions here, but I'm going to keep an eye and hope that you folks can raise your digital hand or ask some questions in the chat while we get started. So I'll I'll start off. I have a question kind of for each of you to start. So, Dougal, could you start by telling us why the company is called Blue Planet, and what that has to do with your product?
Yeah, so the genesis of the idea really is from coral reefs. So all limestone on Earth kind of derives from the skeletons of marine organisms. And so over tens of millions of years, hundreds of millions of years, they die in the ocean, they fall to the bottom, and then eventually get compressed or by heat and pressure into the limestone that we know today. But if you look at the exoskeletons of marine organisms or corals, they're extremely strong, but they're made at relatively or ambient temperature and pressure. Now, obviously, deep under the ocean, there's slightly higher pressure than at the surface, but it's also pretty chilly. And compared to geologic timescales, these marine organisms are making this calcium carbonate skeletons and exoskeletons fairly quickly. And so Blue Planet is kind of inspired by that process. In a way, it's biomimetic. We're mimicking this biologic process in order to create limestone at ambient temperatures and pressures. It's all very well to say you can make limestone out of CO2, but if you're using extremely high temperatures or you're using pressures that require a huge amount of energy, it wouldn't really be worth it. And one of Blue Planet's real areas of expertise is creating kind of a hard limestone at low temperatures and pressures. Precipitating calcium carbonate powder has been around for a very long time, but kind of agglomerating the powder into larger particle sizes is really where a lot of our expertise is, and it gets into the different mineral phases of calcium carbonate. And when it goes well, you know it's gone well, because if you smash the aggregate with a hammer, it breaks into like two pieces, and inside it looks like porcelain. If you haven't done it right, it will like kind of shatter into a powder. It's just a bunch of powder that's stuck together, which obviously isn't what a rock should be like. And so that's really where the name comes from. It's inspired by the ocean.
Yeah, well, thank you. Appreciate the explanation. And I already see a hand up. So, Michaela, would you like to unmute and ask your question?
Yeah, sure. Thanks. My question's for Simon from Brimstone. I was curious if you could talk a little bit more about the alternative raw materials source, and also I'm curious about what temperature that process occurs at.
Sure. Yes, thanks for the question. So the raw material that we use is calcium silicate rocks. So calcium silicate is about 200 times more plentiful than limestone, and so it's a rock you can get in a lot of places right now. As far as the heat, the clinkering process is at the similar temperature to the existing cement process. So it's not a lower temperature process, but because we have the magnesium hydroxide output, it is a carbon negative process. So notwithstanding, our process is compatible with, perfectly clean energy, but even using sort of the average fuel mix that cement companies use today, we're still carbon negative. But we do require a kiln as part of our process.
Gotcha. Thanks.
Simon, sorry.
Yeah, go ahead, Dougal.
Jump in. So is the plan, Simon, to take over existing kilns? I mean, every cement plant I've ever been to, they had a kiln lying there not doing anything because it's cheaper to leave it than demolish it. Or is it to build novel kilns?
I have to talk to our process engineering people about whether we've thought about that. I will say one question that we often get is, could you repurpose existing cement plants sort of in toto? And the answer, unfortunately, is it would be very challenging, because we don't want to have to ship rocks to a site, because that would defeat the carbon benefit. And so we need to build it atop a calcium silicate quarry. And today, most cement plants are built on top of limestone quarries. So, there is a way you can imagine using similar kilns, but, as far as whether we could retrofit existing plants, found a way of making that practical.
Yeah, appreciate that, Simon. And you hit on a couple of the key differences. Are there any other differences you'd want to highlight between Brimstone's product and ordinary Portland cement?
Well, actually, the part that I wanted to highlight the most is that it's identical. So one of the challenges that some of the newer products face is that they are amazingly promising, but there is this regulatory and adoption hill that they're going to need to climb. Our hill, we have challenges too. Our hill is that we need to build scale that is equivalent to cement plant scale. And for those who know, cement plants are enormous. One cement plant serves a region. And so, we ultimately, to get to scale where we are going to be cost competitive with non-carbon negative cement, we need to get to sort of very large sizes.
Mm-hmm.
I would also just point out that as part of our process, we don't just make Portland cement, and and in addition to the magnesium hydroxide, which I also mentioned, the same calcium silicate rock also makes something called SCM, or that's an abbreviation for supplementary cementitious material, and that is currently sourced from coal burning plants of various kinds, either electric generation plants or steel mills. And we have the benefit, and this is actually an economic benefit as well as avoiding subsidizing coal burning plants benefit, that we have a single plant that sources both the SEM, which we don't have to ship in from elsewhere, and the ordinary Portland cement clinker.
Yeah. That seems like a major advantage. And we're interested in seeing Brimstone, really expand across the US. So no hands raised, no questions right now. So I'm going to encourage you all to continue doing that. But next, Lisa, I had a question for you. I was wondering if you could talk to us about your current earth block recipe. I know that you've faced a number of different trade-offs in terms of the environmental footprint, structural integrity, fireproofness, and other qualities. So could you talk to us a bit about that process and where you are right now?
Yeah, sure. So as I mentioned, I'm set up next to the quarry, which I'm obtaining screened clay and sand. It's actually the perfect ratio of sand and clay that I need for compression. If the material is too sandy, it kind of comes apart like a sand castle. If it's too clayey, then we end up with a lot of cracks and fissures in kind of the block. So that kind of 80-20 is a general rule about the ratio of sand to clay to make a good earth and masonry block. I will note that these have been used, for over 10,000 years, continuously used. I always chuckle inside that it's a startup or an alternative building material when it's recorded that approximately 40 to 50% of the world's population lives in a structure of this kind, often because that's all they have to build with. It's difficult for some developing countries to acquire Portland or lumber or steel and things. So this is kind of one of the reasons why it's been at large use. So the mixed design, like I said, is I've been making earth and masonry. I got involved in the early 2000s, typically, using quarry fines to produce the blocks. The addition of Portland cement allows really protects the blocks prior to construction and during construction. It does add, higher compressive strength, and these compressive strengths are roughly in the compressor block realm about half of what a concrete block would be. So an engineer, thinks of these blocks as a little bit of a weaker concrete block. So they do have some limitations as to the heights that they can be applied at, typically 2 or 3 stories. So the mixed design is, in this new interest and wave of life cycle and embodied carbon, I have have gravitated away to the addition of Portland cement, and now, like I said, using lime. I have been experimenting with some local professionals here in the construction waste stream. So what additional material can I add to, as a, if nothing but a filler that would keep the performance and integrity of thermally and structurally the same, but storing material that would otherwise end up on our landfill. And I think there's some real promises here coming soon about what's happening also in the biochemical world with concrete replacements or cement replacements that I can also utilize. So I'm here as a kind of opportunity to let's add some of these materials into the blocks that I'm already producing to further offset the improvement of the mixed design that I'm working with.
Definitely. And one thing I think is interesting about our panel here too is that not any one of these solutions, is going to overtake the others. They all kind of could work in a really nice harmony with one of your companies working on earth blocks, one on a cement replacement, and one on an aggregate replacement.
Lisa,
now,
I had a question, sorry.
Yeah, go ahead.
So in the world of mass timber, like whenever you bring it up, someone's always like, oh, you'll never build a skyscraper out of mass timber. But increasingly, especially in Scandinavia, they have the ply scrapers. And so with the kind of compressed earth blocks, what's the kind of cutting edge of the construction? Like, what are the limits to the building? Like, could we have an Empire State Building made of rammed earth blocks, or is there a...
There, if after this call, if you guys want to check out in Yemen, they call it the Manhattan of mud, and these beautiful buildings that have been in constant use for over 1,000 years. They are 11 stories tall, and it does look like Manhattan of mud. Okay, this is very really hot climate. They've been painted with white limestone to kind of reflect the heat. But the material has gotten some bad reputations in seismic areas. The material is heavy and brittle, and in a shaking earthquake seismic zone, especially when they've been built without any engineering standards, such as a bond beam or such as reinforcing or some sort of containment of the material, right? Thank you.
Mm-hmm.
There's the Manhattan of mud in Yemen. It's impressive. 11 stories, I think, are some of the tallest ones there. It's all out of adobe. It's all out of the material that I've been talking about, a sandy clay structure. So today professional engineers engineer these buildings as if it's a reinforced masonry wall system. It's typically a height to width ratio. So in theory, the wider the wall, the taller you can go. But there are bond beams between the height requirements. So when we can do 3-story buildings, sometimes 4-story buildings, but with concrete bond beams between those levels that help distribute the load throughout. So back to kind of the application of this material, I think as the population increases, we're going to need more density, and we're going to need to figure out how to utilize our land properly. But we're still going to need 2-3-story buildings that can accommodate schools and buildings and build up our our rural or agricultural areas. So yeah, no, it's a great question on the use of it.
No, it's interesting looking back for the inspiration. We think a lot here about pre-steel concrete. So if your concrete is carbon negative, it makes sense that you'd want to use more concrete. And if you look at some structures from before they had steel rebar in concrete, they're still standing, and they use concrete in a different way. Like some of the roofs of like these domes in Florence, or old like aqueducts and viaducts in like Victorian Britain, they're just concrete with no rebar in them, and they're still standing, but they use concrete in a slightly different way, like only under compression.
Right.
And you have to use more, but if it's carbon negative, that's good. That you're using more.
Yeah,
So it's interesting that it's kind of looking back for the inspiration.
definitely. I think that's so important. Yeah.
So I'm gonna interrupt here and hand it over to Trisha, who's just raised her hand with a question.
My question is actually kind of segmented off that same conversation. So the Manhattan of Yemen kind of reminded me of southern India. That's where I'm from, and we use a lot of laterite blocks for construction. They're also earth blocks made of a local stone, laterite, and it's amazing for a humid climate such as in India. And that's where you need like breathable walls because there's a lot of humidity and water. So I was just curious about how these adobe blocks would respond in a more kind of a colder climate, and what's the best climate to have this application for?
Yeah. Such a great question, Trisha. Thank you. And my experience working with Miss Material was predominantly in New Zealand, where I lived for a handful of years in the early 2000s, throughout the North Island. And so coming to Colorado, where it's cold, I had to learn about how to insulate these walls, right? And how to accommodate a thermal insulation. So the wall system now is a double wall with a cavity for insulation between two brick whites or layers. And so this wall system, now we have an energy compliance code that we have to meet, and that's a little bit of a different conversation and challenge with regards to R value and how thermal mass works as a kind of a separate kind of theory. But we do get compliance in very cold climates, like in Steamboat Springs, and be building this double wall system. So that's the answer, is that you have to incorporate thermal mass, which is very good at storing heat and having it move through the wall really slowly, and then with the addition of thermal insulation to kind of resist the loss of that heat. And with regards to kind of the humidity, you're right, and the breathability, the clay and the lime as well allow for that water vapor in the air to be absorbed and released. And it creates a very healthy indoor relative humidity for us around 40%, which is a very healthy place for us as humans to be in a building. And that's
That
all
makes
happening.
sense.
Yeah.
Thank you.
Yeah, thanks.
Thanks, Trisha. Next, I'll go to, sorry if I pronounced this incorrectly, Christianos.
That was correct. Thank you. My question is for Lisa. I was wondering if you have any experience using these blocks in commercial construction, whether load-bearing walls or non-load-bearing partition walls, anything, where we would normally just use regular old masonry concrete blocks.
Yeah, I mean, it's traditionally in the residential realm, right, where homeowners particularly are seeking out this material and wanting this for their own home. So it's been a predominant residential material. However, I'm starting to see a lot more commercial applications and bids that I'm putting out for where they recognize kind of the beauty of the earth and material. It kind of goes with the intent of their design. So yes, I'm starting to do a study with EMU Systems here locally on the thermal performance of this insulated wall I mentioned, and it shows that it has the ability to store heat when there's kind of a quick change. So, in the example of a fireplace where the fire heated the walls, it was able to really store that and keep a steady internal temperature. So the building scientists related to this to say like a church or a school or an office where people are all kind of coming in at the same time, and that heat load can be absorbed and kind of contained and released slowly in a steady way, so that it'd be a great application for a commercial building of that nature. So yeah, I'm currently looking for a school to build.
Got it. Thank you very much.
And you also mentioned, Lisa, that the earthen blocks are typically at least, structurally valid for designs up to 2 or 3 stories. And if you look around, at least like Boulder and Metro Denver, the vast majority of the buildings we're building are 2 and 3 stories. So potentially a lot of applications there, though I know it's quite different.
Yeah, yeah, you can obviously put a framed wall above on top of these buildings, or a concrete garage or foundation underneath. So
Yeah, great. Well, Will Nash, I see you're next.
Thanks. Yeah. So really great stuff. I think we have projects that are screaming out for these materials. So my question really is on supply for all 3 of you. What's your supply capacity right now, and what are your plans, I guess, to bring it to market?
Yeah, so let's start here. Maybe let's go Dougal and then Simon and then Lisa.
Yeah, I would say limited would be an understatement. If you want to build a small building in San Francisco, then potentially we could talk, but the way we're picturing the rollout is really through licensing the technology. Blue Planet won't own and operate these plants ourselves, partly because the expertise is more in rock handling, and 80% of the operation would look like a standard rock recycling, rock crushing operation. The actual CO2 absorption pathway is relatively small, and so that's why we partner with people like Holcim or Central Concrete, which is now owned by Vulcan, and they're the people that will own and operate these plants and use the locally available feedstock. And when we look at the places where we want to roll out to, it's places that, one, have a big green building industry and demand, so those are the usual suspects, but also it's a big business, or it's a massive industry aggregate, and in order to have a big impact and store a lot of CO2, you want it to be as big as possible, and so you need places where you can move a lot of material. So ports, places with great rail links. You don't want to be trucking aggregate around if you can help it, long distances especially. And so our kind of hit list looks kind of like the big ports up and down the West Coast and the South, well, all around coast basically, because that's where the best places are. But Denver is a prime market for other reasons, like there's the green building industry, there's a lot of construction going on. But we just have to kind of balance all of these logistical things, which you don't necessarily think of when you think about climate tech. It's all shiny and lovely, but a lot of it comes down to the same things that the cement and concrete industry has been thinking about for ages: logistics, rail lines, things like that, that will actually impact it. In a way, for us, although we're capturing CO2 is everywhere. Like, it's very rare you'll have a big city that doesn't have some kind of major emitter pumping out CO2, where you have the perfect piece of land served by the right transport links with the right kind of waste material around is really the main thing, rather than the CO2. And so our target is by 2027 to have 5 plants operational in the US. And each of those would probably be 50,000 to 100,000 tons of CO2, which translates to about 250,000 tons of calcium carbonate aggregate, which sounds a lot, but that's not that much compared to a big quarry. And so we have a long way to go. The upside is the aggregate market is so massive and growing that it's not like we're about to push somebody out of it. But yeah, we have a long way to go.
Yeah, and if I can just follow up too, just to ask, you've told us that you're in kind of the earlier stages of being able to roll out to other regions, but I'm also just wondering, is there anything that our membership can do to engage with your product? Anything they can do to encourage its spread to the Rocky Mountain region next, for instance?
Yeah, so we have kind of what we call an affiliate program, which is for people in the built environment to kind of, one, just keep track of what we're doing, but also to start to kind of pool together some of these people in certain regions. Like, we just have this thing going in Seattle at the moment. Obviously, all the tech companies, all these huge architects there, and it's kind of a case of where they're pulling the product and pulling Blue Planet towards that region rather than the other way around. And so, yeah, I think definitely I can connect you with David Gottfried, who works here as the, he's kind of in charge of that affiliates program, and he would be keen to kind of, yeah, see where the demand is and kind of pull the product to them rather than, for instance, 5 years ago, it was all about where's the CO2 being emitted, let's capture that and then find the market. And now it's kind of flipping around.
Great. Yeah, if that's if his contact information is something we can share with our membership, we'd love to send that in our follow-up email, because we have
Yeah,
you know, designers, practitioners, but also some folks from government who I think would be interested.
yeah, absolutely. I'll pass that along.
Great. And Simon, same question to you, both on, you know, the supply and availability of Brimstone's product, but also, is there anything that our membership can do to engage with Brimstone at this point?
Sure. So I think, you know, Blue Planet and us and Brimstone seem to be on sort of at a similar stage. You know, where we are is we've proven our technology at the lab scale. We can deliver the same materials. Our process works. Now we are advancing towards construction of our first pilot plant. We've acquired land outside of Reno, Nevada, where we are going to, you know, prove out our systems, because, you know, it's a process that has some similarities to existing cement production, but also has some important differences. And, you know, we need to make sure that we can, you know, build at a commercial scale. And then at the same time, we're looking for a location. You know, Rocky Mountain area is among the places that, you know, have usable rocks and have, you know, some of the same characteristics that Dougal was saying are important around rail links and access to markets. And so we are hoping to identify a site in the relatively near term for a very large plant. But, you know, just to give you perspective, I've heard that a conventional cement plant takes, and that's where you have pre-existing systems, pre-existing designs, pre-existing financing, you know, it takes 2 to 3 years, you know, from site selection through to construction, and sort of $500 million to $1 billion. So this is a process we are, you know, seeking to accelerate as fast the process as much as we possibly can. But, you know, our next step is this pilot plant. And as far as, you know, being involved and connected, we don't have an affiliate program yet, but we are building one. And so in the interim, you should feel free to email me directly, Simon@brimstone.energy, and I'd be happy to sort of plug you into future information releases. But yeah, we're just, you know, we're on an acceleration path right now. But we, you know, really the technology was invented less than 2 years ago. So we're, you know, happy with the progress we've made, but we're not selling cement for a little while.
Yeah, I recognize this is an especially hard question for earlier stage startups, but we're excited for even if it's 2 or 3 years out for your product to come out. Now, Lisa, you're in a very different position. Tell us how people can engage with your product.
Yeah, currently accepting orders. For the first time, you know, this is a niche building material, right, in an industry that's extremely slow to change. So I've been patient with educating and really spending a lot of time educating, networking, getting some awareness out of this product, and which is starting to show quite a bit of traction now. And you know, I typically 80% of my clients are block clients. People that purchase blocks are my clients that I'm designing for, and so I kind of you know what's coming in terms of block production. And this is the first year that I've keeping my plant operating during the winter. So you know, improved infrastructure, cover for the material, cover for the guys making blocks and gals, and And so, the block production with the press that I have can make about, it has a capacity for about 2,000 blocks a day. And an average size 2,000 square foot house might require around 5,000 blocks. So, these also have to cure and kind of be, palletized and wrapped before they can be used for construction for about a month for that curing process to happen with the lime. But yeah, there's, and then growing or needing to expand production looks like acquiring another machine and or other facilities in other locations. So that would be my growth strategy, is to identify other quarries and other, locations of which we could go and set up additional facilities so to reduce transportation costs in other locations. But really servicing, I'm shipping blocks out to Union, Missouri next summer. I've sent blocks to Wyoming, and so there's not really any commercial folks that are brave enough to do this. And but yeah, currently producing as not today because it's snowing, but have been producing this, will produce through the winter as needed. And like I said, come visit me in Golden if you want to see the production.
Lisa, is the clay that you're taking from the quarry, like, is it providing a service for that? Is that otherwise a waste?
Yes, it's what they call an overburden.
Yeah. So
it's I purchase it for $4 a ton. It's very inexpensive. It comes to me. We call a joke that it's kind of like this mountain, right? Their mountain of clay that they have just been storing, and so.
Yeah. I mean, shouldn't you be paid $4 a ton? I mean, that's the thing that we come up against all the time. Like, we're taking waste materials, but everyone's like, "Oh, that's not a waste. That's a precious pile of rubbish."
Yeah,
like,
I mean, they're a company too, right? So they do screen it for me, which is probably what I'm mostly paying for. Getting it down to kind of the 3/4 size, which I have to screen further once it gets to my plant. But yeah, no, that's a good. It's a very similar material that we put on our baseball fields here in the U.S. To give people kind of a context of what it feels like. It's beautiful, and the color of the clay is what dictates the color of the block. So kind of our really reddy orangey clay here, dries to a really nice light peach color. And that color never fades over time. It stays that color for its life.
One thing I just thought of if you want to engage, if any of you are going to be at Greenbuild in San Francisco next week, we're having a tour of our plant on the 4th. So I can, if anyone's interested in that, just give my email address or whatever. We can try and fit you in.
Great. Yeah, I know that some of the folks on the call will be there, so hopefully they can go. I'm jealous that I'll be missing out.
I was going to add about the engagement piece. I am wanting to kind of share the information with other architects and engineers, people that would like to learn how to design these with this material. People might not be familiar with the reinforced masonry wall materials. So I'd love to do lunch and learns with folks that would be interested to have kind of a webinar type thing or in-person lunch and learn. So that would be, I'm happy to. It's not going to grow and expand if we don't share the knowledge. So that's love to do so.
Definitely, and I'll include that offer in our email as well. So I have a question and Cristianos has a question. I will hand it off to him first, and then I'm going to ask you all a question about cost. So you can let that noodle around in your head. But Cristianos, please go ahead.
Thank you. My question is, I think mostly for Dougal, but either of you feel free to jump in as well. I'm curious about the compatibility with other like low embodied carbon concrete technologies. Like, could you take Blue Planet aggregate and use carbon cure as well, or Portland cement coming out of a Brimstone facility, or those are a couple examples, I guess. But how are those intercompatibilities working?
Absolutely. I mean, there's no chemically, there's no difference from limestone you get out of the ground. If anything, it's slightly purer. It doesn't have the whatever was in the ocean when the marine organism made its shell all those hundreds of millions of years ago. Yeah, it's all about, and I think this is something that probably people in our industry slightly overlook, is the actual complexity of mixing concretes. So just like if you change to a different aggregate from a different quarry, you would do the whole suite of tests. It's just the same with our aggregate. It's just a new material, and there's no reason why you can't use carbon cure. You can mix it with SEMs, like when we work with Central Concrete here in the Bay, like their standard mix uses 30% SEM. I think they even have a 70% SEM mix as well. And they're obviously interested in combining the two, and anyone interested in buying Blue Planet aggregate, it makes sense that they also be interested in the 70% SEM or 50% SEM mix to just drive things as far as possible. And so, yeah, it's absolutely just like you would think about mixing any materials in a concrete mix. It's just the same thing, really. There's no special reason why it can't.
Perfect. Thanks for that, Dougal. So my last question, and we still have a few minutes, so people feel free to raise your hand or drop something else in the chat. But my last question is if each of you could just address current cost for your product and kind of cost trajectory, because I know trajectory is big, especially for you, Simon and Dougal. But I'll switch the order up again. We'll go Simon and then Lisa and then Dougal.
So, we obviously don't have commercial cement on the market right now. We make 3 products instead of just one product. So we have the cement, we have the SCM, and we have this magnesium hydroxide, which under various carbon removal and offset schemes also has a market. And so, our expectation is that at scale, we will be able to sell our cement and SEM at competitive market prices. There'll be a ramp up period. The demand for low carbon materials is very high right now, and we expect the demand to outstrip the supply early on, particularly at a moment when we only have one plant or just our starting. But our plan is to get to a point where we are cost competitive. And I will say that this is particularly important to scale overseas. Right in the United States, there are various subsidies. The IRA, the Inflation Reduction Act, was very powerful in the kinds of incentives that it creates around low carbon building materials. But we can't expect the entire world to subsidize these kinds of low carbon materials, and this is a global problem. And so, that's a mission of our company, to keep the price competitive, because if it's not, we worry that we'll lose the fight for just focusing on the countries that are rich enough to subsidize low carbon materials.
Perfect. Thank you. And then Lisa, you're up
Yeah.
next.
So it's like the number 1 or 2 question I get, right? How much of these these walls comparative to timber frame, which is the predominant buildings material now. So so our walls are typically cost by square foot of wall area for the the masonry and the installation itself, which is it's approximately $52 for the blocks and installation. And of course, this is very dependent on where you are in the mason's ability, travel and kind of location of the site and things like that. But those are very general costs, of which I'm understanding is very much lined with other masonry wall systems such as ICF or Faswall, which seems to be some of the other systems that people take under consideration when not looking at frame. So other metrics are the walls are about 20% of the cost of the structure, maybe 15-20% of the cost of the structure. They are Masonry is always going to be a little bit more than frame because you're getting a, you know, different durable material. There's usually a more of a foundation that needs to go under it to support it. So there's always, you know, and then of course the offset of the operational cost and kind of the maintenance as well. These walls don't have to be painted. They don't have to be maintained in the same way. There's no drywall on the inside. This is a lime plaster finish that can last indefinitely. So yeah, they're just other kind of trade-offs when you look at kind of the cost of the product. So yeah, definitely.
And then Dougal, I think you're last for our question on cost here.
Yeah, everybody's favorite question and my least favorite question. The answer is complicated and it will probably be different in every single plant, but in the basic way to look at it is that what we are trying to avoid is being priced as a competitor to rock, because we will lose. What we want to be priced compared with is other ways to decarbonize the building. And if you think about that, it's actually surprisingly cheap. I mean, the great thing about aggregate in concrete is there's absolutely loads of it. Like 70–80% of concrete is aggregate. So in a concrete building, the vast majority of the building by mass is aggregate. And if the aggregate is 44% CO2 by mass, that's a huge amount of CO2 in the building. And you can potentially offset all the embodied carbon of the building. And that's something that's hard to price because it doesn't really exist like without offsets at the moment. And so someone would say, oh, it's price competitive, but it only does a 5% reduction. So how do you price something that has 100% or even 200% reduction? And when you think about it that way, it kind of comes back to the value of the CO2. And so when we're talking to the Microsofts of the world, they're thinking about it like, on the one hand here, I'm paying whatever, I mean, Microsoft pays insane prices, but let's say $200 a ton to remove the CO2 from the atmosphere or for these high quality offsets. But at the same time, if I reduce the embodied carbon of my new building by X tons of CO2 and it's trapped within the fabric of the building, maybe I should value that at $200 a ton. And so it's more about thinking about the amount of CO2 reduction in the building and pricing that versus the rock. It's almost like the rock is just a benefit that comes with the CO2 reduction or the CO2 that's being stored in the building. Now, there are other ways to think about it as well. Like in some cases, the emitter that we're taking the CO2 from will take all the credit, and in which case we'll just get paid for them and it will be conventional rock. Or it might have some other high value, like it's extremely reflective or it's lightweight. But yeah, I'd say the way to think about it is competitive with the cost of decarbonizing, but more expensive than rock dug out of the ground.
Right, and that makes sense because you're not just digging rock out of the ground. You're going through an additional process.
Mm-hmm.
I feel like I have 10 follow-up questions just to that, but we are at time and I want to be respectful of people's lunch hours. So I just wanted to thank you, Lisa, Dougal, and Simon so much for your time.
Thank you.
I'll follow up with each of you around next steps here because I think we promised people to share some contact info and we're going to encourage people to go on that tour at Greenbuild, Dougal. So hopefully some people can check out your plant. But yeah, thank you, all three of you, and thanks for everyone for the good discussion.
Thank you, Matt.
Thank you.
Thanks,
Thanks for the
everybody.
questions, everybody.
yep.
All right, have a nice day.
Nice lunch.